Hello everyone, we're supposed to Thrive and Survive, July 7th, 2015, and we have covered this subject once before, but this is going to be a very definitive covering this time with a lot of the errors that I had in there before, which was talking about too many different things at one time out of the way, and this is going to be pretty quick with this presentation, hopefully. And then I need to get into Greece and what's going on there. Again, for those of you who have not watched maybe the economic reports, get your money out of the bank, get your investments in your name, street registration in your name. Do it now. Do it now. Do it now. And I will be coming back. The next video will be economic, and it is really it is hitting the fan, just like Lehman Brothers hit the fan. You just haven't seen it yet. Okay, so those of you who may tune into this but don't tune into the economic reports, you may want to tune into the next one. If you have any money of any consequence anywhere in the world. All right, that's how much is going to be affected. Okay, uh, this is going to be the proof that everybody is going to, I hope, enjoy uh, about how we can tell that the Earth is not moving, and we can prove this day in and day out with common sense. And we are going to break down some definitions that I didn't break down last time because I didn't think it was necessary. Now what happens is a lot of people will come and look at my videos, and what they will do is they will go Google search something real fast, like they'll come up with this sidereal time, which is actually the correct way to pronounce it. I've been pronouncing it wrong. They will look up sidereal time and say, aha, I got you. You're dumb. This is a dumb video. And they do all the calculations and they put it down there. And not only do they call you dumb, but they throw all kind of other things in there to make themselves look smart. Now, I'm hoping some of these people after this will see that they've been lied to. They believe the lie. And I'm hoping that some of them will switch over and start helping us get the truth out with this. Okay, this, believe it or not, ties in to the new economic program that's coming in. And I will do a video eventually which will, I guess we'll have to do it pretty soon because they're bringing in the New World Order pretty quickly here. All right, now we're going to talk about the difference between sidereal time and solar time. Notice on solar time, okay, what this is indicating here is one part of the Earth is always facing the sun every 24 hours exactly. The same spot on the Earth faces the sun every 24 hours exactly. With sidereal time, it's a spot on Earth faces a star in the background, okay? Once every 23 hours, 56 minutes, and so many seconds. And we're going to get more specific with that, so let's get to it. Now let's get a little bit more specific with the definitions. A sidereal day is 23.93444696 hours. All right? A mean sidereal day is about 23 hours, 56 minutes, 4.0916 seconds. And then they give the exact all the way down to the 7th or 8th decimal place. Okay? Or, this is very important, a sidereal day equals 0.99726 mean solar days. It's solar days we're going to be looking at, not sidereal. We'll look at both, how they're affected. All right, but people Google this stuff and they say, see, you're dumb. It's not 24 hours, it's 23.93. That's correct for a sidereal day. What they don't do is they don't do their homework. They got this got you mentality, plus they want to believe the lie anyway. And then they call you dumb, throw this out there, and then they think they're the hero. And then people come back and behind them and click like it. They like it because they proved me wrong, so to speak. When all they've really done really is they've made fools of themselves. Okay, he who judges a matter before he hears it all, it is a fool, he is a fool, and it is a folly unto him. Okay, now a sidereal uh, day is as the Earth goes around the sun, all right, about 1 degree every day gets off-centered, all right, with stars in the background, all right. It has nothing to do with the sun. This has to do with a point on Earth facing a star, okay, one day. The next day, it's a little bit off what it was before, the star. The next day, it's a little bit off with the star in the background. This is necessary for the progression of the different astrological signs. and we'll show that in just a second. Solar day, different than a sidereal day. The time interval between two successive transits by the sun of the median directly opposite of the plane. What that means. It's very much easier than what that says. The 24-hour interval from one midnight to the following midnight. And there's different kind of solar days where it could be noon to noon or some other time to some other time, but it's always a 24-hour exactly. Now I typed this in here, 24.0000 hours. How did they come up with 24 hours exactly? No matter how many decimal places you take this, it's zeros. 24 exact hours. Okay, what they did was they picked the spot on the earth, okay, in this case at noon. And how long did it take for that spot to come back and face the sun exactly? All right, directly overhead 1 day later. All right, and with that they said, okay, whatever that interval is, we're going to make it an even number. All right, so they took that and said that is going to be equal to 24 hours. And then they broke that down into 60 minutes equals an hour and 60 seconds equals a minute. And so they defined a solar day by what the Earth did, not the other way around. They didn't say, oh, time equals this, and then how long does it take to come around? 24.23. No, 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 no. They made it so 1 day facing the sun on the same spot every day on the Earth is 24 exact hours. Now, because the Earth sometimes in its orbit is elliptical, means it's a little bit farther away at some parts and a little bit closer than others, and it's a little bit faster in its orbit than a little bit slower at other times. No more than a 3% variance, folks. It's very small. Now, what does that mean with a solar day? Sometimes the solar day can be 16 minutes off of another solar day, never back to back. But let's just say during January when we are going fastest around the sun because we're the closest, okay? It might be as far as 16 minutes off a perfect 24-hour day from one other day on the orbit. It can never be more than 16 minutes off, and it's not additive, meaning it isn't 16 hours off today, 16 minutes off today, and then another minute tomorrow, so it's 17 minutes off now. No, no, no. It's never more than 16 minutes from whatever your start point was in the year. Okay, it self-adjusts. By the time the year is up, even by the time a month is up, it's back to exactly 24 hours a day. Okay, it's a non-factor. Hope that makes the difference now between what a solar day and a sidereal day. A sidereal day, again, is 23.934496 hours. This is based on the stars in the background coming back to where they were the day before. This is the odd number. This is what changes as you go through time. And we're going to show that that is necessary, and you'll see how it makes sense. And those of you who say, I got it wrong and I'm dumb, think about all you had to do was do one extra step to see if there was one other day definition. And there is. It's called a solar day. Okay, this is called laziness and jumping to the quickest conclusion you can to have these gotcha moments on somebody. All right, let's stop that, shall we? Okay, guys, this is really, really cool. It really is. This is how you can show anyone, you can guarantee them, you can prove that we do not orbit the sun. There is no way around this. Okay, what I have done here is I have drawn what's called a meridian line on this Earth here. Okay, now the dot in the middle, we're going to act like we are the sun. We're looking straight down at the Earth. Okay, we're the sun looking out at the Earth. Okay, when this meridian line is right in the middle, see that just represented by the white dot there, it is 12 noon. Okay, now in one 24-hour period, the Earth rotates 360 degrees. All right, now in case you don't know, on the compass, all right, 0 degrees and 360 is the same thing. There's 360 degrees in a circle. So at 12 noon, we're going to say this is 0 degrees. Okay, it's 0 degrees to the sun. Correct? It's directly facing the sun. 6 hours later, this meridian line is right on the edge here. Okay, which would be 6 p.m. and let's just call it sunset. All right, now sunrise and sunset is going to vary throughout this time, and I know about the 23.5 degree tilt. These are non-factors, guys. We really don't care about sunlight, times of sunlight and darkness in this example. We don't care, and you will see that. Okay, so uh, 6 hours later, what has happened? The Earth has rotated 90 degrees, and that same dot is on the horizon over here. All right. 6 hours later, all right, it's midnight. The backside of this globe is now in total darkness, and we're going to put the shading in a little bit. All right. It is now 180 degrees turn from this point. All right. 0 degrees, 90, 180. That line is on the other side. All right. 6 hours later, it's now 6 a.m. sunrise. All right, that meridian line now appears again. It's on the horizon. Okay, and it is now 270 degrees rotated. And then at 12 p.m., we come back to the start point. Okay, it has rotated 360 degrees. It has completed one day, one 24-hour period. It comes exactly back to facing the sun again. No variation. It's not like a sidereal day. A sidereal day will understand that in a minute. All right. Hopefully this makes sense, and I'm trying to do this so you can always go back and watch it again. So if you missed it the first time, you can get it again. All right. I'm going to zoom in here for just a moment. I'm building up the model for us to look at. This dark side over here, it just represents the side that is not facing the sun. All right. Like I said, we're not too worried about the little variations it's going to have through the year or the tilt or whatever. We're not concerned about that. It doesn't matter. What matters is when the same side of the Earth faces the sun again. We have the sun in the middle. This line represents the orbit around the sun. Yes, it's slightly ecliptical. It's a slight ellipse. All right, but that doesn't matter either, and we will see that. All right, and I showed arrows. Believe it or not, some people, they do not see that the sun comes out all sides. It does. Even the arrows up here I didn't put in. Hopefully you understand that if the sun is in the center, everything around it is lit up. Okay, so we have the Earth on one specific day here. All right, and this would actually, this dot now would represent more like sunset. Okay, everything on the right side of the Earth is in darkness. On the left side would be in light. Okay, sort of like what they say about the moon. Now, everything I say in this video is what science says, unless I say otherwise. We're using the science model here. Okay, now let me zoom out and let's get a bigger picture. Actually, before I zoom out, let me bring another concept in. We have this right here. We have the dark side and the light side, okay? And what we're going to do is we're going to put squares on it like this, just to easier, represent the time of day on the Earth, okay? So in this case, we're saying because it's all lit up, we're at the sun looking out at the Earth, okay? The red dot on the edge here, that represents sunrise around 6 a.m. Around noon, okay, or at noon would be the white square here, and around 6 p.m. would be sunset. Again, these are going to vary a little bit as far as where the shadow is, depending, what time of year it is, but the Earth it's still going to turn 360 degrees in one day. It doesn't matter where the shadow is. Please don't get hung up on something that matters not. Okay, we are going to use next year, 2016, okay, it has 366 days in it. It is a leap year. Some people get hung up on the fact that 365 days divided by 2, that's going to make the difference. It's people not thinking it through. It really is, okay? So we're going to use a leap year, all right, so you can see how there's no dividing of odd days, all right? So I picked January 31st, and the only reason why I picked that date is because that happens to be one of my son's birthdays. All right, and half a year is 183 days, so I added 183 days to that, and that would be August 1st. So that would be exactly 1/2 trip around the orbit of the Earth in a year. Okay, hope you got that. Now, in January, They say it is that is people born in January to, is it January 20th to about February 20th, something like that. They're called Aquarians. Okay, their birth sign is Aquarius. Why? It's because the sun apparently from the Earth is in Aquarius. All right, you can never see Aquarius in January and February. Why? Because the sun, the Aquarius is the backdrop for the sun. So people born in January are said to be under the sign of Aquarius because the sun is in Aquarius as it relates to the Earth. See, if you're on the Earth, you're looking through the sun here, Aquarius is behind it. And you can't see it because it's out during the daylight. What you can see is Leo the lion at night, okay? So if I was to do this, if I was to take this, the position of the Earth, move it around, okay, to this side on August 1st, all right, what would you have? You would have people born in August, they are said to be Leos, all right? And I don't know if this goes from July 20th to August 20th, probably does. You can tell me if you know any differently, but anyway, roughly those time periods, okay? And what happens? That means in August we can actually see Aquarius in the sky because we're looking away from the sun, correct? Um, and the sun is in Leo, so um, people born in August 1st, for example, they are Leo. Now, if I move it up to May 2nd, okay, what are those people? Okay, you have to look through the sun during the day. That's Scorpio. So Scorpio people are in early May, so probably late March, early May, I think is how that one works. And then if you go over to November, okay, those are Aries people, okay, um, because you're looking through uh, yeah, April to May, I guess is what it is. Whatever, May 2nd is going to be Aries. If I said that wrong the last time, when the Earth is over on this side, they are Scorpio is what they are because the sun is in Scorpio. Okay, I hope you see that. And when you're over here in November, you can see Aries at night. Does that make sense? Okay, that progression is the sidereal day, and you're going to understand that in a second. Okay, so um, let's get rid of this and go with this other model up here. Just a moment. Okay, this is the model we're going to be using right here. Okay, here's the Earth. Okay, the red is going to indicate, okay, that it's 6 a.m. sunrise when we start. 12 is 12 noon. Okay, I'm sorry, we're not going to use this one. This is not correct. Let me select another one. Okay, we've got it right now. This was actually correct. We had the times wrong. All right, so the red on the horizon here, facing the sun, because we're going to start on this side, okay, will be 12 noon. The white dot will be 6 p.m. and the yellow dot will be midnight. Okay, again, this shadow is going to go back and forth a little bit through the year. It doesn't matter. The shadow doesn't matter. What does matter is what part is facing the sun. And every 24 hours, what happens? The exact same spot on the earth faces the sun. All right? I hope that makes sense. That's very important. The exact same spot on the earth every 24 hours exactly faces the sun because the earth rotates 360 degrees on its axis, tilted or not. It turns 360 degrees once every 24.00 hours. Okay? Okay, the very first day we're going to start. Here we go. All right. It's 12 noon. Here's our guide up here. 12 noon. Why? Because this edge of the earth right here, this red part, is facing directly at the sun. Okay. And people born on January 31st, they are Aquarians. They are said to be in the constellation Aquarius because the sun appears to be in Aquarius. You cannot see Aquarius in January because the sun is in the sky in the same spot. All right. What you can see on the yellow side, okay, at midnight, you can see Leo the lion. All right. You can see that constellation. All right. Hope that makes sense. So what we're going to do is we are going to progress around. We know every 24 hours there's a 360 degree um, turn on the Earth. Okay, exactly. All right, so day 1, day 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. 15 days have gone by, okay? We are still, um, every 24 hours, what happens? We come back to the exact same spot. Where do we start? We started with the white spot directly facing us from our vantage point. It's still directly facing us from our vantage point. All right. We go about 90 days around, and we already have a major issue. Okay. Again, every day that we pass, the sun turns exactly 360 degrees on its axis. It faces the exact same spot. All right. It's facing us, but look, the red part is no longer facing the sun. Okay. Let's keep going. We go all the way around, exactly halfway point, the exact halfway point, 183 days later. Okay? Do you see the problem? Okay? Do you see the problem there? The problem is it is now midnight. Okay? The yellow position, okay, facing away from the sun, that was the midnight position. It is now facing um, see how it's backwards? Like the light part of the earth is reversed. It should be the dark part, okay? Um, so there's the problem with the solar day. This proves we do not go around the sun. However, with the sidereal day, it's perfect with that because why? Because in August, people are called they are said to be under the sign of Leo the lion, right? You look at the sun, there's Leo the lion. The sidereal day worked correctly, all right? But the solar day did not, okay? So let's take that off. Let's do it again, one more time, okay? We start here every single day, all right? Remember on the sidereal day, every day these areas here, some star in the sky would rotate about 1 degree. All right, which makes sense. 183 days later, you're about 183 degrees different in the sky than you were over here. All right, let me see if I can get this to actually do what I want it to do. Hold on just a second. Okay, what I did was I just flipped this. All right, because the lit part is over here. All right, and the dark part is over here. All right, and unfortunately, the um, the whole thing is wrong. Okay, let me go back to the way it was, just to show you. Okay, after we moved it 183 days, all right, the problem is that we have the dark side facing the sun. All right, and this is still pointing at us. Okay, but it's actually flipped around. Do you see the problem? Okay, the problem is it's off. So there's no way we go around the sun. I don't care if you make this ecliptic and change it all. That has nothing to do with it. All right, the same part on the Earth faces the exact same um, position to the sun, according to science, every 24 hours exactly. And every 24 hours we go roughly 1 degree. It's not quite, so it's slightly less than 1 degree up every time. So when you get about 90 days, you're up here. 180 days, you're here. 183, you're here. All right. And when you get down to 270, okay, you're actually, all right, starting to come back in to where it should be, but you're off through the whole year. You're really off here, okay? So your clocks are way off. They're 12 hours off when you get to the other side exactly when halfway around. Even though the constellations are right, the sidereal day works, but the solar day does not. And the solar day is exact 24.00 hours. Okay, the Earth has to face the exact same position again every 24 hours. All right. There is the problem. Folks, we do not go around the sun. Okay. Now, how can we solve this problem? We can solve this problem very easily. All right. Forget about the sun. I'm just going to put the earth here for a second. We'll put the sun in a different spot later. Let me make this a little bit larger so we're not thinking we're looking at the sun. Okay. There's the earth. Okay. What if every 23.998, whatever it is on the sidereal day, these rotate around? Okay. So let's take Leo the lion here. I'll just take a little piece of him. Okay. So he's not at a scale. Okay, we start him, okay, and he rotates around, okay. The ether, the stars are in the ether, so is the sun. It rotates around, okay, every 23.99 whatever hours, okay. If that's the case, all right, we don't have the problem with the earth facing the sun anymore, and we still have the correct days lining up for everybody's birthday and their signs in the constellation. I hope that makes sense. All right. And all you guys that said I was dumb or whatever, you didn't do the homework deep enough. Okay. Americans in general, for the most part, I don't know about the rest of you, probably Britons too, but you tend to jump the gun. You find the first thing, and then you have this, aha, gotcha moment. There we go. The ether moves around the Earth every 23.9344696 hours. Okay, put the Earth here. All right, and we've said if you haven't seen the sun how it goes around the Earth on the flat Earth model, you need to look that up. That's taken care of as well. All right, but if you make the Earth the center, okay, like the WMAP probes make the Earth the center, all right, it all works, and these move around us. Thanks, guys. I hope that made a lot of sense to everybody. To me, there's no way to disprove this. And if these are moving around every 23.9 days, I mean hours, that makes total sense because they line up every single year. All right. Now, these right here, these aren't perfect either. All right. That's why every 4 years we need a leap year to get these back into position, not the sun, to get these exactly back to where they should be in the sky. Otherwise, they would start rotating on us. And even that isn't perfect. What has to be done is every 4 years we have a leap year, but if the 4 years is divided by 200, I think, no, 400 equally. If 400 goes into the year equally, then you skip a leap year. So every 400 years, that 23.999 whatever is still off enough to you have to even compensate every 400 years. But guys, the whole thing, the whole ether revolves around us. We are stationary here. It makes total sense then. Okay? Total sense. And then what you have is instead of the earth out here, you have the earth rotating around us. Okay? That's what you have happening. The Earth is in the center stationary. The sun is actually in a smaller path here. You know, I'd have to make the Earth much larger. And then these rotate around, and it works perfect. This model works perfect. This model, where we go around the way science says, does not work at all. It fails. And if it fails, it's wrong. The whole thing has to work or it's wrong. That should be self-evident to everyone. Thanks, guys. Really, seriously, I know this video will be out there for a long time, but as of right now, we are having the Lehman Brothers moment, and CNBC and the rest of you are lying to you by saying it's not a big deal. That's the same thing they said about Bear Stearns. It's the same thing they said about the housing crisis. It's the same thing they said about Lehman Brothers. This is a bigger deal than all of those combined, and I'll be talking about that. Take care, guys.